All right, honors geometry. So the next type of segment we need to talk about is a median. So a median is a segment whose endpoints are a vertex and midpoint of the opposite side. So a median is connected by a vertex and a midpoint. So here's your median. And again, we know this is a midpoint right there. So when the three medians meet, right? So the three medians meet, they create this 1/3, 2/3 relationship. And again, I'm not too concerned about that, but the intersection is called the centroid. Okay. Now, this centroid is also known as the center of gravity because it is the exact point where a triangular shape would balance. Okay, would balance. So think about that. If it's the point where it would balance, where do you think the centroid is always going to be, right, as we construct? Okay, so let's take a look here, and we can do this pretty easily in Desmos geometry. So I'm going to make another triangle ABC. Again, nothing special, just trying to make it an acute one. Here's A, there's B, there's C. Okay, let me move B over here so it's not. There you go. And to do this, so I need two midpoints. So let's do AB and BC's midpoints. So more tools, midpoint. And now you just connect the opposite vertex to that midpoint. So this midpoint here, the opposite vertex is C. This midpoint here, the opposite vertex is A. And where they crisscross right here, that would be what's called the centroid. Sounds like a cool character from a video game, right? Centroid. And again, if you notice, as I move C, so this is an acute triangle, right? As I move C, so B becomes a right angle. It's still in the center. And then when I make B obtuse, it's still in the center. Okay, or I shouldn't say in the center, in the triangle. So that's the centroid. And then the last one we have to talk about here is called the orthocenter. What a cool name that is, right? So before we talk about orthocenter, we need to talk about the altitude of a triangle. So the altitude of a triangle is just a perpendicular from a vertex to the opposite side. So now be aware that sometimes your altitudes must be drawn outside of your triangle, and we will discuss that in a second. And again, these lines are all concurrent, and for some reason I don't have this idea, but it's called the orthocenter. Let me go fix that right now. Okay, so there's the orthocenter. That's how you spell it, right? Orthocenter. Okay. Sorry about that. So let's go ahead and construct the orthocenter. All right. So if we go back to Desmos geometry, let's create that triangle, just a generic triangle, ABC, nothing special. A, B, C. So now the orthocenter has to involve the perpendiculars. So let's do our perpendicular from A across the way. So I will construct a perpendicular. It has to be perpendicular to the opposite side. So if I'm going through A, this is my opposite side, BC. And here's A, so there's my perpendicular. And then the same thing, construct a perpendicular through this segment AC through B. So there's my two perpendiculars. Let's put a point where they meet. This would be called the orthocenter. So notice it doesn't involve anything about midpoints, right? So now again, as I become more equilateral, notice your orthocenter is kind of in the center. When my angle B becomes a right angle, look what happens. The orthocenter becomes the vertex of the right angle. So that's an interesting idea. And then as I go outside, watch what happens to A's. Look at what happens to the perpendicular through A as I become obtuse. Notice, look, this perpendicular is outside of the triangle. In reality, I'll use this ray and I'll color it. In reality, what's happening is we're extending that side length. I use orange. Okay, so we still have this segment here, which hopefully will cover it in blue. Yes, sure. Okay, but when we extend it, now this perpendicular is outside the triangle. So this is still the triangle here, right? But now we extended it so that this perpendicular is outside of the triangle. And if you bring angle B back to being acute, it goes back inside. Right angle and then obtuse, that perpendicular goes outside. And your orthocenter goes outside the triangle. Okay? So be aware of that. All right, so in the next video, I'm going to show you how to make this Euler line.